Hi student, welcome to this new video still on Gauss Reduction. In this video, we will give you how you can apply the Gauss Reduction method. Now, the Gauss-Jordan reduction algorithm is presented as below. The first step, right, is you should start with the first column. If all entries are 0, then move to the next column to the right. Secondly, if to the contrary, the column has non-zero entries, interchange rows if necessary to get a non-zero entry at the top. This is very important, and we have a deeper look on this when we do some examples in this video. The third step will be to multiply the top row by a constant to change the non-zero entry to a leading one. Remember, we saw what the leading one was. And fourthly, if there are non-zero entries above or below the leading one, use elementary row operation on each one to change it to a 0. Very important. The fifth step will be have to repeat steps 2 to 4 for the next leftmost non-zero entry until all the leading entries are 1. And lastly, swap the rows so that the leading entry of each non-zero rows is to the right of the leading entry of the row above it. Okay, now let's have a practical example. So you have this, and you are asked to Gauss reduce this matrix 1, 4, 7, 10, 2, 5, 8, 12, 3, 6, 9, 15. Now, as a solution, we need to have a close look on the steps, right? And how to apply them. Now, if I write my matrix here, this is my matrix 1, 4, 7, 10, 2, 5, 8, 12, 3, 6, 9, 15. Okay, we said that we should start with the first column. So, and this is a leading entry of the first row is already 1, so that's fine. And we say that everything above, right, a leading entry or below should be 0. So we need to try to make this this term here 0. So we will do that R1, right? Sorry, R2 instead. We'll do that. R2 is replaced by R2 minus 4 R1. So, and then if I also check, I can also have a 0 here. If I do that R3 equals to R3 minus 7 R1, because I have 7 here. And then I can also have 0 here. So it will give me R4 equals to R4 minus 10 R1. Now, apply this will give me this matrix. I will have 1, 0, 0, 0, right? And if you apply this multiplication, right, you have that here. I will have 2. I will have minus 3 because it will give me that I have 5 minus 8, so minus 3, and then I will have minus 6, and I have minus 8, I will have 3 minus 6 minus 12 minus 15, right? So I have minus 6 here because I have 6 minus 4 times 3 minus 12. So it's 6 minus 12 minus 6. So I have minus 12 here because I have 9 minus 21, right? And so forth and so on. So I have that. Now, what I can again do here is that I can do I can divide this to have a 1 here, a leading entry 1. So I will do that. R2 equals to R2 divided by minus 3, right? Which will give me a matrix of this shape 1, 2, 3, 0, 1, right? 2, right? And I will have 0, minus 6, I will have minus 12, I have 0, minus 8, minus 15. Now, on this matrix, I can have the remember we said that we should have 0 above and below the leading entry 1. So I need to have a 0 here, right? And it's 2. I need to have a 0 here. And I need to also have a kind of 0 here. Okay, so how do I do that? So I've noticed that if I do R1, if I replace the first row by R1 equals to R1 minus 2 R2, right? So I will have also that R3, right, equals to R3 plus 6 R2, right, to have 0 here. And then I will have that R4 will also be equal to R4 plus 8 R2. And then this will lead to, I will have 1, 0, minus 1. So, which I obtain my 0 in the first row. So I will have a 0, 1, 2. I have 0, 0, 0. And then I have 0, 0, 1. Okay. Now, okay. So now what will happen right here in this case? You see that the next thing I should do, I have to swap these two rows, right? Because we say that the rows of all 0 should be at the bottom. So I have to swap these two rows. So swapping, I will do that. R3 will be swapped with R4. Okay. So I will have that 1, 0, minus 1, 0, 1, 2, 0, 0, 1, and 0, 0, 0. Okay. So I swap. So I have the bottom having my the row of all zeros. So what happened here next is that um, I I can do so I can also reduce, right? I can also reduce the if I do so what will happen here if I do that yes, so if I do that R1 is equal to R1 plus R3, right? I will need and then if I do because I need a 0 here, right? Because I need a 0 above and below a leading 1. So and then I will also do that R2 equals to R2 minus 2 R3, right? This will give me that I have 1, 0, 0, and then I will have 0, 1, 0. You have 0, 0, 1, and 0, 0, 0. So you can see that this therefore is a Gauss is a reduced row echelon form of our matrix A, right? So it means that you have that uh, from A, which is 1, 4, 7, 10, 2, 5, 8, 12, 3, 6, 9, 15. The reduced row echelon form of A is written as 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0. Okay. I hope you enjoyed this little video, and in the next video we will solve a system of linear equations using the Gauss reduction. Thank you.